Our project is titled Distributed Cloud Based Transaction System, DCTS in short, which is a distributed banking system which provides consistent money transactions. So, moving on to the design and implementation, it supports four major operations: deposit, withdraw, check balance, and multi-way transfer. And the main algorithm which is used to implement this is Paxos, which was invented over a decade ago by Leslie Lampert and is mostly used for getting computers which can talk with each other to agree on something. Important because we have unreliable machines and network and also multiple machines proposing different values. The main advantage of this algorithm is that it's quorum based, so only a simple majority of the only live servers which are present in the cluster is required for the whole cluster to agree on something. There are three components of it. One is proposer, second is acceptor, and third is learner. In all these three phases, you need to have a majority of the nodes to come into an agreement before we can move on. So that means if a system of five, then you need three to be in agreement before you can move on. Before we move on, we have a single concept of lock, which is based on mutual exclusion, which means only one person can access the system at a time, which may be an account or a file. So in the first phase, or else prepare or propose phase, the proposer proposes for lock. Second phase is the decision phase where the acceptors decide whether to provide the lock. If the lock is provided, then all the acceptors log it on the disk. And while the lock process is happening, if any of the failed nodes comes up online, then they are updated with whatever the process has happened in this learning phase. In our project, before any transaction happens, the lock is acquired first. We have used Python to write the code. Please make sure you have JSON pickle module before trying to run the code. Banking system file has the backend transaction code. Distributed transaction client file has the client side of code, and the distributed transaction server has a server side of the code. Test run transaction is a test file and its output is provided in a test run transaction output.txt file. Output is in terms of a log. First 4 or 5 lines in the log are like the initialization and the starting of the servers. Here we have used 4 servers, one client, and we can see on line 12 that it is asking for a lock, and after that the client is connected to the back. Till line 80, the proposal and acceptance phase happens where server 1 is sending the proposal to 2, 3, and 4. And it receives acceptance from the servers and the lock is delivered, and after that the transaction is then again sent to all servers in the learning phase and it is replicated on each server. On line 90 we see deposition successful message with the transaction details. Similarly, all the other accounts are added. On line 957 onwards we see the complete bank account details and the corresponding log details. One thing I would like to point here is that all the servers and clients are running on separate threads, and Paxos and banking transactions are separate, and each transaction happens only after the log from Paxos is acquired. Moving on to the advantages, which are that it provides safety. That means once the proposal is accepted, any other process will not have access until and unless this process completes. The second one is eventual liveliness, which means that if things go well sometime in the future, there is a good chance that consensus will be reached, but there is no guarantee. It also reduces the load as there are many servers as opposed to one, so the load is balanced and there is no bottleneck. Disadvantages are that the processes may fail and the majority does not include it, and messages can be dropped and the protocol may never end. So it does not provide consensus but eventual consensus.